Welcome to the next teaching unit in the chapter PV grid integration. In this lesson, we'll take a closer look at the concept of active, reactive and apparent power. You have probably heard the terms active, reactive and apparent power before. Since active and reactive power have a special significance for our power grids, I would like to go into these terms in more detail here. In an AC network, current and voltage have a sinusoidal characteristic with a frequency of 50 or 60 Hz respectively. Ideally, the maximum values and the 0 points of current and voltage in an alternating current occur simultaneously. We can say current and voltage are in phase. The phase shift phi between voltage and current is 0 here. A special characteristic of alternating current is that certain resistances have an influence on the phase shift. While a normal ohmic resistor causes no changes in phase shift, this is different for coils and capacitors. In the case of a coil, a magnetic field is generated by the periodic current changes. This magnetic field causes an induction voltage, which is greatest when the current changes is maximum. At the peaks, the current change is 0, so no voltage is measured here. As a result, the voltage precedes the current by a quarter period. The phase shift is plus 90 degrees. If, on the other hand, there is a capacitor in the circuit, the current flow causes electrons to accumulate on the capacitor plates. By charging the capacitor plates, an electric field is built up which causes an electric voltage. The voltage is always at a maximum before the direction of the current changes, which leads to a polarity inversion of the capacitor. In the case of the capacitor, this causes the current to rush ahead of the voltage by 90 degrees. The phase shift is minus 90 degrees. Since coils are in all motors or transformers, a certain amount of phase shifting actually always occur in AC power systems. In addition, power lines themselves also cause phase shifting. Multi-core power cables act like a capacitor, while overhead power lines can be thought of as extremely stretched coils. Let's now take a look at the power flows. The power is the product of current and voltage. At the ohmic resistor, the power pulses between 0 and a maximum value. With the coil and the capacitor, however, it looks different. With both, the current always reaches its maximum value when the voltage is 0, and vice versa. As a result, the power becomes alternatingly positive and negative. This power is periodically drawn and delivered again. On average, the positive and negative power components completely cancel each other out. Thus, no power is consumed. This can be explained by the fact that the capacitor and coil each draw energy to build up the electromagnetic field, but then immediately release it again when the fields are reduced. The power that oscillates back and forth in the circuit as the fields build up and decay is called reactive power. In contrast, the power consumed by an ohmic resistor is called active power. Let's summarize the terms again here. We have learned about active power. This is the power that can actually be consumed by an electrical load. In physics, it is denoted by P and expressed in watts. The reactive power, on the other hand, is a power that is not consumed, but is used to build up electromagnetic fields. It is denoted by the letter Q, and to distinguish it from active power, it is not expressed in watts, but in var, VAR. The designation VAR comes from the French words volt, ampere, reactive. In reality, the case where only active or reactive power is drawn almost never occurs. The lines of the power grid must therefore transport both active and reactive power and be sized for the overall currents that occur. The total transported power is called apparent power S. It is specified in the unit volt-ampere. Finally, we can define the so-called displacement factor, cosine phi. Phi corresponds to the phase shift between current and voltage. The displacement factor is a measure for the part of the apparent power that is converted into active power. The relationship between active, reactive and apparent power can be visualized in a power triangle. With the help of this power triangle, the different power values can be easily converted into each other. Depending on the sign of the phase shift, the reactive power can be positive or negative. The sign of the reactive power can easily lead to confusion, since it depends on whether the system is considered in the consumer or in the generator sign convention. We choose the generator sign convention for our consideration. Here, injected active power is counted positively and consumed active power is counted negatively. Reactive power is defined as positive if inductive reactive power is injected. If inductive reactive power is absorbed, the reactive power is negative. In the case of a generator, positive reactive power is also often referred to as overexcited operation and negative reactive power as underexcited operation. Note that the terms are reversed in the consumer sign convention. Often people talk about reactive power without specifying the sign convention. This can quickly become confusing if you are not aware of this fact. Similar to the distinction between active, reactive and apparent power, we can also distinguish between resistance, reactance and impedance. The ohmic resistance limits the current flow in a system and is designated with the letter R. The reactance is the part of the overall opposition to current flow that is due to the capacitance, an inductance, or both. It is given the letter X. Finally, the impedance is the total opposition to current flow in an AC circuit. It contains the resistance and the reactance and is abbreviated with the letter Z. Resistance, reactance and impedance are all measured in units of ohms. The relationship between them results from a triangle, just as with the powers. Let's summarize the teaching unit. Inductors and capacitors cause a phase shift between current and voltage. Depending on the amount of phase shift, pure active power, pure reactive power, or both are transmitted. Active, reactive and apparent power can be converted into each other via the displacement factor cosine phi. In the same way, the impedance, reactance and resistance as well as the displacement factor are related to each other. I thank you for your attention.